Welcome back everyone to the series 1 episode 2 of Pre-Calculus 11. Today we're gonna start to go in about more practice questions about rational expressions. As you cover the new topic is you cover the NPVs, which is the non-permissible value, and we go also a bit of simplify. So we're gonna go through a couple of questions here together. So here are the questions about rational expressions. So I will scroll down a little bit here so you guys can see what question we're gonna be working with. So today we're just gonna work through 2 pages for these questions. So there will be 26 questions total. So I have you guys have a look here. So all the questions numbers here I will put down on the chapters in the description so you guys can skip ahead to see what question you guys want to focus on. But for this YouTube video, I will working on the whole question together. So let's zoom in first and then let's get started together. So the question here is simplify each expression, but also let's add on state the NPV as well, because we need to know what numbers cannot stay at the bottom of the denominator, because when the denominator has 0, they are not very happy fraction. That's what we call math error. So let's simplify this. So first we have 36. I take cross out. I can divide all of them by 6. So 36 divided by 6 gives me 6, and then 7. This will give me negative 6 over 7. X with the power 3 and x with the power 2. My x on denominator will cancel out, and my top one, because I have the higher degree, I take 3 minus 2, I will have x with the power 1. So therefore, I'll have minus 6x over 7. Now we need to state the non-permissible value, because the final answer, we do not have x, but we need to state is that what do they give us initially at first on the question, because they give us the x value here. So therefore, we're gonna put x squared not equal to 0. Then I square root them both sides. Then I will have x is not equal to 0. So that's my NPVs. Again, NPV is where the number cannot be 0 in denominator. Next, question 2 here. So the first thing I can see is 16. I can cancel them out. R2 cancel out with the R3. I will have R with the power of 1 here. Then I will have 1 over R. NPVs I will have is R is not equal to 0. Pretty simple. Question 3 here, we have 16 over 28. I want to focus on a number first. I do know that 16 and 28, I can divide it by 4. So that will give me 16 divided by 4 is give me 4. 28 divided by 4 give me 7. P squared will cancel out, give me 1. And P raised with the power 1, or P with a degree 1, they will be cancelled. So I will have P, 4P over 7. And my NPVs is going to be P cannot be equal to 0. That are to my answers for this question 3. Question 4, 32 over 24. I can see that I can divide by 8. So 32 divided by 8 will give me 4 over 24 divided by 8 will give me 3. N will cancel out because n with the power of 1 in denominator is lower than the degree number on the numerator. So the n at the bottom cancel out, and then the n on the top I will give is n with the power of 1. So that is my simplified answer, and my NPVs is going to be n is not equal to 0. Next, we're moving on to 70n squared over 28n. So we need to find a number that can divide the number first. So I can divide it by both by 7. Negative sign still there. 70 divided by 7 will give me 10. 28 divided by 7 give me 4. But that is not all. I can go further, but let's do that a bit later. I will have n squared is 1, n cancel out, so I have minus 10n. So now I can simplify further by dividing by 2, then I'll have minus 5n over 2. And my n is not equal to 0 because the question is given is n, so I will say n is not equal to 0. Next, I have 15 over 30. I can divide by both by 15 because 15 times 2 will give me 30. So I will have 1 over 2. N cancel out on the top because they have the lowest degree. 3 because here's the degree is 1. 3 minus 1 will give me 2. So I have n with the power 2. So I have 1/2 of n squared. Then my n cannot be equal to 0. Okay, now we're moving on to a little bit more complex on question 7 here. So we have 2r minus 4 over r minus 2. The numerator we can do by greatest common factor by take the 2 out. So I will have r minus 2. Remember, because 2 divided by 2 give me r, minus 4 divided by 2 give me minus 2. That's why the 2 is outside, and this is what I have inside the bracket. I will have r minus 2. They cancel out. And now I have 2. That's my answer. For NPVs, r minus 2 not equal to 0. To bring minus 2 to the right side, I add 2, I add 2, so r will be not equal to 2. Next, do the same thing. 45 remain the same, but the 10 at the bottom, I can take it out, put it outside the bracket, then I will have a minus 1. 45 and 10, I can simplify further by dividing by 5, then I will have 9 over 2 of a minus 1. So in this case, you can use 10a minus 10 or a minus 1 here. They both will give you the same answers. So in this case, I will use a minus 1 as well. So a minus 1 not equal to 0, plus 1, then I'll have a not equal to 1. Let's use 10a minus 10, 10a minus 10 to give you guys an idea that we have the same answer as well. I add 10, I have 10a not equal to 10, divide by 10, divide by 10, then I'll have a not equal to 1. So we have the same answer here. Okay, let's move on. So we have x minus 4, so I will keep x minus 4 the same. On denominator, I can take the 3 out as my number. Let's put the 3 down first. And the x, I see that we have common factor is x, so I can bring another x outside the bracket. Then I will have x minus 4. It's my final answer. So x minus 4 cancel out, then I'll have 1 over 3x. So in this case, we only have 3x, but I would also want to use this so I can do more practice. So 3x times x minus 4. So first one is 3x not equal to 0. Then I'll have x not equal to 0. And x minus 4 not equal to 0. Then I'll have x not equal to 4. And this is my final answer for simplify. Next, we're gonna simplify on the numerator by taking 3 out. So I have 3, 5a minus 1 over 24. 3 and 24 can simplify further. I have 1 and then 8. So I will have 5a minus 1 over 8. Question 11, v minus 5. So they are really simplest on numerator. I keep the same. But down here, v squared minus 10a plus 25. So they are basically perfect square trinomial, because perfect square trinomial is where a minus b squared equal to a squared minus 2ab plus b squared. Another perfect square trinomial is a plus b squared, but in this case, because they are negative, we want to focus using the right perfect square trinomial formula. So you see here v squared and a squared here, they are corresponding the same as perfect square. 25 here and b squared, they are perfectly correspond as square because 25 is a perfect square for 5. And then 2ab, because v we have is 1, and then here we have 5, and then here's negative times negative 5 equal to minus 5 minus 5, then we'll have minus 10. So this is my perfect square trinomial for v minus 5 and v minus 5. And now we have v minus 5 on the top. We're just going to cancel them out. Then I will have 1 over v minus 5. That's my simplified answer questions. And for my NPVs should be v not equal to 5 because v minus 5 not equal to 0. I add 5, I add 5, so I will have that answer. We don't need to do twice because since we have two brackets the same, you don't need to solve two times because we will have the same number anyways. Next we have x plus 6 over x squared plus 5x minus 6, x plus 6, and then this will be our inspection factor. Remember what we did from last episode. We need to find a number that times together give me minus 6, but also when we add they give me positive 5. So we only have one choice here, is either minus 1 times 6 or 1 times negative 6. They both give me negative 6, which is correct. But when we plus this, minus 1 plus 6 give me 5, but 1 minus 6 gives me minus 5. So this is wrong, this is correct. So therefore what I do, I will have x minus 1 and x plus 6. This is my factor form. Now we simplify by cross x plus 6 out. Then I will have 1 over x minus 1 is for my final answer for simplify. For NPVs, I would like to do 2 as well. So we're gonna get familiar with how to do work with NPVs. So x minus 1 not equal to 0. Then we will have x not equal to 1. X plus 6 not equal to 0. Then we will have x not equal to negative 6. So that are my two NPVs to work with. Now on second page, the question a bit more complex with factoring. So if you guys practiced a lot on the last episode about factoring, this will become really handy to solve this question along with NPVs and rational expression. So let's work together. So I can take 9 out. So I have 3x plus 2. Then I can cross this out by divided by 9. So I will have 3 over 3x plus 2. I want to use this. So 3x plus 2 not equal to 0. I will have 3x not equal to minus 2 divided by 3. Then I will have x not equal to negative 2 over 3. Okay, question 14. Now we need to factor both of them, top number and the bottom, which is the numerator and denominator. So let's factor it together. So they both inspection. So if you want to spend a bit of time to factor, feel free to pause. When you're ready, just play the video back again. So when you factor, you should have v plus 3 and v minus 10 over v plus 3 again, and then v minus 8. Now we have v plus 3 the same, we cancel out. Then we will have v minus 10 and then v minus 8. Let's work with the 3 brackets number at the bottom to find my NPVs. So my first one is v cannot be equal to negative 3. The second one is v cannot be equal to 8. That's my answer for simplifying. Next, question 15. Feel free to pause again if you want to have a bit of time to work with. When you're ready, play again the video. So here, let's simplify by factoring first. So I'll have v plus 6, and then v plus 2 for my numerator. Denominator, I will have v minus 3, and then v plus 6. for the 6. Yeah, I just double check. So v plus 6 cancel out. I will have v plus 2 over v minus 3 is my simplified answer. Then my NPV is v cannot be equal to 3, and then v cannot be equal to negative 6. Next, question 16. Again, it's still inspection, both numerator and denominator. So I will have v minus 9 and v minus 2 over, it's not v, I'm mistaken as the variable as v from the previous question, so let's change that. So this one they give me x, and this will give me x, 4 and 2, so I will have x minus 2 and then x plus 4. So minus 2, they cancel out. I will have x minus 9 over x plus 4. My NPVs will be x not equal to 2 and x not equal to negative 4. Now question 17. Now we have inspection on numerator, but difference of square in denominator. Remember, difference of square is where we have first term and second term, they are perfect square, but we do not have the middle term. But also another way to know is we have the negative sign. That's how we can confirm we have a difference of square. So let's factor the top one first. So we'll have b minus 4 and then b plus 7, and then over b plus 7, then b minus 7. b plus 7 plus 7, they cancel out. Then we'll have b minus 4 over b minus 7 is my answer. My NPV is going to be b cannot be equal to negative 7 and 7. That's question 17. So we are 3/4 way so far. Now we're going to keep moving on to a bit more complex question down here. 18. We're moving back to both inspection. So when you factor, you should get v plus 5 and v minus 8 in the numerator, and we will have v minus 8, then v minus 3, minus 8 to cancel, then we'll have v plus 5 over v minus 3, then NPVs cannot be equal to 3 and 8. Now we come back to greatest common factor. So 4 taking out the bracket, then I will have n minus 1 inside the bracket. 6n minus 20, I can take 2 out, then we'll have 3n minus 10. 4 and 2, we can simplify further, so I will have 2n minus 1 and then 3n minus 10. Let's bring down to find NPVs. 3n minus 10 cannot be equal to 0. Then we have 3n not equal to 10. Then n cannot be equal to 10 minus 10 over 3. Next, question 20. When you factor on the numerator, you will have v plus 2 and then v minus 7 over v plus 2 and then v plus 2. This is perfect square trinomial, because perfect square trinomial is a plus b squared equal to a squared plus 2ab plus b squared. So perfect square, half of 4 is 2. When they add 2 and 2 together, we still have 4, so they are perfect square trinomial. Now let's simplify. V plus 2 cancel out. Then I will have v minus 7 over v plus 2. My NPVs is going to be v cannot be equal to negative 2. We only state once, remember? Because they are identical, we don't need to state it twice. Next, question 21. Greatest common factor on the numerator. 6v squared, bring it out. Then I will have v plus 7. Then I will have 2, take it out. So I'll have v squared plus 13v plus 42. Now we need to keep factor this further. So I will have equal 6v squared v plus 7 and then 2. Now we'll have v plus 7 and v plus 6. So v plus 7 cancel out. 6 and 2 can simplify further. I will have 3 and 1. Then I'll have 3v squared over v plus 6. My NPVs is v cannot be equal to negative 6 and negative 7. Question 22. Let's bring the x out. So I'll have x squared minus x minus 42. And then 2 is x squared minus 10. X plus 21. Then we need to factor further. Then I will have the top one is x plus 6 and then x minus 7 over 2 x minus 3 and then x minus 7. They are both still inspection, but now we have x minus 7, we cancel out. Then I'll have x plus 6 over 2 and x minus 3. This I will have my final answer. For my NPVs, cannot be equal to 7 and 3. We have 4 questions left. So question 23 here is we take 2 out again. V squared plus 5v minus 24. 8 we take it out. So I have v plus 8 in my brackets. Then equal to 2. Then v minus 3. And then v plus 8. 8. So we have v plus 8 here as well. V plus 8, they're the same, we cancel. 2 and 8 I can simplify further. So I'll have v minus 3 over 4. And then I'll have NPVs is v cannot be equal to negative 8. Next, 24. I'll have 9x taking out. And then x plus 9. Then I'll have x squared plus 8x minus 9. Then I'll have 9x, x plus 9 on my numerator. And then we need to factor further on my new denominator. Then I'll have x plus 9, then x minus 1. X plus 9 cancel, and we see the x here outside the bracket, they are the same, we can cancel them out as well. Then we will have 9 over x minus 1. That's my answer. Next, this question, the number is big, but let's factor the top one first. So when you factor this, you should get x minus 8, x plus 10. We take the greatest common factor out is 2x, so I'll have x squared minus 12x plus 32. Then I'll have x minus 8, x plus 10 remain the same. 2x outside. Then I'll have x minus, what do we have? X minus 8. Then x minus 4. X minus 8 cancel out. Then I will have x plus 10 over 2x and then x minus 4. I'm going to use this to find my NPVs, so x cannot be equal to 0 and also 4. Last questions for this video, episode series 1. So we'll have 3 r squared minus 13 r plus
Bring fun
30.
to life. The Instax Mini Link 3.
Now that's a holiday classic.
Just like you.
Okay, let's moving on to the last question of episode 2, series 1 of rational expression. So here we have 3r squared minus 39r plus 90, so I can take 3 out. So I will have r squared minus 13r plus 30 in my brackets. Now we'll factor at the bottom, so we'll have r plus 7, then x minus 10. I need to factor the top further. No, it's not r squared. I just typo there. So I'll have r minus 10, r minus 3, r plus 7, and then r minus 10. So r minus 10 the same, we can cancel out. So I'll have 3 times r minus 3, and then r plus 7. So that's my final answer for simplifying. My NPV is going to be r cannot be equal to -7 and also 10. And here is the recap of our video for today that we practiced a lot for simplifying and finding the NPVs. I do know that when you do NPVs, the teacher will be giving you the different direction, is that they want the NPVs on the final answers. But in this practice, I want you guys to do a lot from the factor, so we would know how to find NPVs as well, because when you do multiplication, division later on, you would need to find NPVs a lot while you do calculation. So this is basically a good way to practice for you guys to get ready for later on for rational expression, more detail. So this is it for episode 2, series 1. Next episode, we're gonna do more practice on rational expression, on adding and subtraction, multiplication, and division. And we also have solving, which is the last part as well, but that's a lot to say. But I will see you guys in the next episode.